Hello everyone, welcome back to another video. So in this video we are going to dive in a cool um, topic, but it's in the same time a complex topic. Well, this actually it's a part of mathematical functions. We're gonna actually introduce you to math.noise. And well, what is this function that are called math.noise? Well, this function, uh, it's actually an abstract method of algorithm that are called Perlin noise. Well, what this Perlin noise algorithm do, or what it serves for, it just makes a table or an array of um, values that are random using a seed, and in the same time not that complete random. Well, every parameters, like, it's better in application. You're gonna know it's better when we get into application actually. So let's do it right now. First, I don't need this base plate. This is the first thing. Now, what we want actually to do with this math.noise. First of all, we want actually to make a terrain. Well, a random terrain, or actually for now we're gonna make just a flat terrain out of blocks. So let's do it. I'm gonna make first of all the block that we want to draw, or like to create, or instance, get an instance of it. It's 4 by 4 by 4. Okay, and I'm gonna make sure to anchor it, and I'm gonna make it grass and the green color. Okay, cool. Now we have this grassy thing. Well, just got that brightness a little bit. Okay, so we have that grass block. I'm gonna call it a grass, or just grass like this, and I'm gonna place it in a folder called blocks in replicated storage. Blocks, or actually I'm gonna make it, or anyway, I'm just gonna go into replicated storage and get this grass part and drag it into blocks folder in the replicated storage. Okay, cool. Now I'm gonna make a script in server script service like this, and I'm just gonna zoom in for you a little. Okay, and now let's actually include or store in a variable the server script service. So server script, actually not server script service, sorry, replicated storage, because we want actually to access this blocks folder that holds all our blocks instances and objects. So anyway, local rs equal game get service replicated storage. Okay, I'm just gonna zoom out a little. Cool. Now local blocks equal to rs, and we're gonna use wait for child, because replicated storage folders, there's a big chance that when this script runs, the replicated storage content doesn't loaded yet. So we're gonna make sure just wait for it if it's not existent, like exists. So yeah, wait for child, and we're gonna do blocks. We should wait for child that are called blocks, and this is the folder. So yeah, and now let's just get, or never mind. So yeah, now I'm gonna make a function called create that, well, that holds the block name, and the position. This is all of it. So yeah, this function gonna create or put a block by the block name that we given it, and in the specified position, or pose. So first of all, I'm gonna look for the blocks or the block by its block name. So I'm gonna do local block equal to blocks find first child block name. So we're trying to find a block with the specified name in our blocks folder. That's what we are doing here. And now we're gonna check if there is this block or not. So if it wasn't there, then we're just gonna do warn. We're just gonna warn the player, or actually just output yellow text in the output that there's no block, like there's no such a block in the specified block name, so, or the specified name in our blocks folder. Anyway, there is, or can't find the, and I'm just gonna concatenate the block name point. I'm just gonna do this point, or no need to point again. Can't find the block name, for example, can't find the grass block, or the block name block. So yeah, just make sure that we debug correctly if there's any error. So now if we found the block, then we want actually to instantiate it or clone it. So local, we're just wanting to copy it, and yeah, so I'm just gonna call it new equal to block clone, just with a colon and the clone function. Well, this clone function, what it does, it just clones any instance, like it's a child or a function of any instance in the game. So it just clone it, or just copy it, and we start here in the new thing. Well, when you clone something, it's just its parent, it's nil, so its parent nil. So we need actually to specify the parent here. So new dot parent equal to workspace. So we can't see it, because if we didn't parent it, sorry, I'm gonna back in some seconds. Okay guys, I'm back. So what we did here, we just cloned our block, our specified block from our blocks folder, and then we just parent it to the workspace so we can actually see it, because it's parent in default. When you clone something, it's null. Well, you can see it, you can just see whatever stuff or objects in the workspace, but some other services or nil, you can't see it. So we want actually to see it. And now we want actually to position our new block, or the block that we just cloned, in the correct place, or the correct specified position. So now let's do it. So new, but here I don't want to actually set the position property directly, because there are gonna be some problems if I did so. By the way, if you don't know C-frame and stuff, just go to my later, or actually recent, previous videos, so, and you can find some videos about C-framing and stuff. So anyway, I'm gonna set the C-frame, not the position. So new.cframe equal to cframe.new. Well, I'm making a new C-frame value, and I'm just gonna pass in the position, or our specified position. Well, the position gonna be a vector tree, and the cframe.new takes one parameter. It's a vector tree position, and it takes actually a lot of other parameters, but we just passed in the position right here because we don't need any other thing. So here we're good, but let me tell you something here. We actually setted the new, like we parent um, our block into the workspace, and then we edited its property or its position. Well, for optimization, you should actually change all the properties that you want to change and then parent it, so you can have some like optimization in the rendering, because well, changing properties takes a little bit of extra um, rendering process in Roblox Studio engine. So it's better actually to change all the properties that you want, then parent the object, so we can just have a little bit of extra optimization, especially when you're talking about some infinite terrains and stuff on the some big games. So you really should edit your properties that you want to edit, and then just parent it back into workspace. Cool. So now we actually just optimized a little bit, but well, this optimization doesn't gonna like um, seem to have a difference for you, but it's actually have some difference in nanoseconds and stuff. Well, that nanoseconds really matter in the game. So yeah, now we have our create function, right? But we don't call it yet. So now let's just call it, so we can make sure that it's working like. So I'm gonna pass in grass as the name, so it's, as you see, it's a string of our block name, our target block name. So I want actually to instantiate this grass part or this grass block and set its position into vector3.new 0 comma 0 comma 0. Well, I'm making a new vector tray which holds three values. It's the position in the x and y and z axis. So let's see what's gonna happen. Is this gonna be good, or there's a bug or whatever? So yeah, let's see what's gonna happen. So let's look around. Okay, so we have our actually our block here. Cool. Now let's see what we have. So as you see, the position 0 comma 0 comma 0, and our grass block, it's in the workspace. By the way, we didn't change it, actually we didn't actually use our block, we just actually instantiate, like cloned it, then we actually parented it and changed its properties. So yeah, that's cool. Now let's just test our debugging thing right here, just to show you that it's working. For example, I want stone, but well, stone, I doesn't have any block or parts called stone in my blocks folder. So let's try this up. Can't find the stone block, as you see, and it's working. So if you click it, actually you can go to the source, and as you see, it's gone into here, into the script and in the line. And that's cool for debugging, just if there is any problem with stuff, and just makes your code really easy to debug if there is anything wrong. So here, what we want actually to do, so we actually want to make a set of blocks. Well, for example, if we want to make a set of blocks in like in tape, just using the create function, like grass comma vector3.new 0 comma 0 comma 0, and then I can just copy this line and do like this, and just actually add to the x-axis 1. So I just made a grass block in the position 0 comma 0 comma 0, and another grass block in 1 0 0. Okay, so let's see what the results actually. Okay, so we're seeing actually something wrong right here. So we have our block are interfering with the other block. Well, why? Let's see our positions. So the first block is 0, 0, 0, and the other, well, this is 0, 0, and this is 1, 0, 0, as you see right here, and so and that in the x-axis. So here, why that happened? Because our block, it's of size 4, 4, 4, not 1, 1, 1. So it's really obvious. So now actually let's just make it 1, 1, 1, so we can see what I'm meaning, like 1, 1, 1. Okay, so we have our block here, just 1, 1, and we can see it right now. Okay, and our other block 1, 1, 1. Oh, sorry. 1, 1, wait, what's going on? What's going on? 1. Oh, I think, yeah. Okay. As you see, when it's size 1, 1, 1, it's actually correct. But well, when it's 4, 4, 4, and that was the result. So that's a really easy fix. You just in like in place of adding 1 by 1 by 1, you should add by the size. And well, let's do that. So we're actually gonna do, well, actually let's return the actual block. Return, so just our new cloned block. Cool. Local block 1, or anyway. So yeah, let's just make a variable here called size equal to vector3.new and set it to your default size, or your block's default size. So now we can just do size dot x, of course. Let's run. Or we can actually do something better. We can just do that here, just so simple. And then here, in place of position, we're gonna do multiplied by 3, or actually by size. You know what I mean? So pose multiplied by size, and this should work fine right now. Cool. Now let's just make some more grass blocks. So 0, let's do here 1, let's do here 1, just like that. Let's see our results. Okay, so I see we have 4 blocks right now, one in 0, 0, 0, and the other 4, 0, 0, the other 4, 0, 4, and the other 0, 0, 4. Cool. Okay, not bad at all. Now we really don't want, so for making a terrain, we don't want actually to manually just place in a lot of functions and just repeat that. Well, when I actually told you to repeat, you maybe, if you're smart enough, you're gonna remember loops. Well, loops are just used for actually repeating a piece of code or a block of code. So we can use that actually. So let's use it. Now we don't gonna use a simple well, let's just use a loop. So I'm just gonna do for x equal to 0, comma 10 for example, comma 1 do. So here what I'm doing, well, this code gonna run 10 times from, well, actually 11 times because we're starting from 0. Well, let's just do it 1 anyway. So from 1 into 10, it's just gonna start counting, so, and incrementing by 1 and actually storing the iteration value in the x. So if we actually printed the x right here, we can get our value. So as you see, that code runs 10 times, 1 2 3 4 5 6 7 8 9 10, and as you see, that x value holds the current iteration or the current, so yeah, current run. So we can use that actually, so we can create a row of blocks. So let's do it. Create a grass, comma, and I'm gonna give it vector3.new, and I'm gonna pass in x, comma 0 in the y and 0 in the z. Now let's try it out and see what the actual thing that we've got. Oh dear, that's actual crashing. It's really annoying. But anyway, because I have the actual recording screen software, and my PC, it's just a potato anyway. So as you see, we have 10 blocks. As you see, 10 items, and they are all grass blocks in the workspace. Well, here in the workspace, we actually, it's really annoying to have all these blocks shown up in the workspace like that. It's really annoying. So it just make a model for it, and I'm gonna call it, for example, Terra. Why I didn't call the terrain? Because we have already a terrain instance of ROBLOX smooth terrain. So we actually want to make our own terrain, and I just got this cool name right here without actually interfering with this terrain instance right there. So we can actually, in the place of workspace, we can do workspace dot Terra. Okay, so we actually have our blocks right now in our model that are called Terra. But now let's see here. So we actually now have a line of blocks, so we can actually now make a lot of blocks, for example 100. But here, before actually getting into really large numbers, so the bigger the number of iterations and the bigger the number of blocks, the bigger the lag is. So we're actually gonna add this wait function here just to make sure we don't crash out because of the repeating process. So yeah, cool. As you see, it's actually gone, and yeah, cool. Now if we want to make a terrain, we actually want well, now we have just a one dimension terrain, just in a one dimension. As you see, we can't now do something else. Well, now we want actually to make a 2D terrain, like a two-dimensional grid of blocks. So as you see, now we just have 100 blocks in a row in one dimension. We can't do none or less. So what now if we want actually to make a second dimension, we need to make the actual current iteration or current dimension a nested loop for our new loop. So anyway, for z equal to 1, 100, 1 do end. So as you see, our last loop, it's inside our new loop, and that's, yeah, and that should makes us a two-dimensional terrain. And we're just gonna replace that 0 in the z-axis with the actual z iteration. So if we run right now, we should have, okay, we should have a Lloyd terrain right here. As you see, because of our weight function, it's loading like just 1 by 1 every 1 by 30 second, or so. Yeah, let's just get this weight function out of here and let's see what's gonna happen. Well, I don't really want to do 100 by 100, so actually 100 by 100 is gonna give us, let's do it here, even if I know, just to show you. Well, sorry, oh dear, 100 times 100, and we have 10,000 blocks that are gonna generated. And well, my PC really can't handle 1,000 blocks in the same time, or actually not really in the same time, but in the same second. Well, there is a difference in nanoseconds, it depends on the processor, so but we really don't want to do that in ROBLOX. So yeah, I'm just gonna go with 10 by 10, and 10 by 10, it's, well, 10 times 10, it's 100, and well, that's affordable without a weight function. So as you see, we've created now a 2D terrain, a 2D flat terrain. Cool. Okay, of 10 by 10 in the 2 axis. Now I want actually to make it 16 by 16. Well, 16 by 16, and this is gonna be a chunk of Minecraft, but 2D, not 3D, because Minecraft have a 3D chunk. So now we actually have a terrain of 16, or a chunk 16 by 16. Cool, as you see all these freaking blocks. So select children. As you see, we have 256 items, because 16 times 16 gonna give us 256. And if you wonder how actually the process goes in with these loops, you can just make a wait function right there. Well, notice that I'm not doing the wait function here in the x-axis, so I just doing it in the first loop. So it's gonna create a row in the same time and another row with a little bit of a wait function. So if we run right here, we can see that thing. So as you see, freak cool. Let's just wait a little bit of time so we can notice what's going on right there. Okay, 0.5. So as you see, every 0.5 seconds we getting a new row of the Z, like we're increasing the Z axis. So really cool. Now what if we want to do a 3D dimension, even if we don't want that, but just as an extra thing? So for y equal to 1, 16, 1, so we can have a square chunk, or actually a cube of blocks. Okay, and I'm actually gonna make a plan by a plan, just like this, and let's run it up, and we should have this. Well, what we did wrong, oh, because we're not actually replacing the 0 with y, this y thing, this y loop. So yeah, and as you see, we're starting to get some cool stuff. Cool. And now we actually have a cube as a terrain, and that's awesome. So this is a 3D terrain, and what we actually use just a 3D loop, well, 3 nested loops, X, Z, and Y, and yeah. Okay, that's awesome. Now what we wanted to do here. Okay, back. So what we actually have here, so it just created, but wait, control Z, control Z, control Z, just to fix this. Okay, cool. Now let's just get the switch function out of the way. Now we can actually generate 16 by 16 by or times 16, so it's 4096 blocks. That's huge. I don't think this might be, well, actually it's actually got it without any wait function and in freaking some nanoseconds, as you see. Cool. Now let's just stop. I don't actually gonna work with the 3D dimension because, well, math.noise doesn't work with, well, we can work with it actually. Well, let's just go with it anyway. So now we can just make this just as generate chunk function. Okay, just some modifications. It's not necessary, but just like it. Anyway, so generate a chunk, and of course you're gonna need to give it a position. And well, what we're gonna do with that position, we're just gonna do position plus that. And now what we can do, actually, we can just do generate chunk vector3.new 0, 0, 0, and then the same line of code, just gonna add some 1, and let's see what's gonna happen. Okay, so we actually have 2 chunks, but well, there is some blocks interfering with another's. At least I think 16. Now let's see, because our chunk, and yeah, we have now 2 chunks. Awesome. Well, cool. Now just gonna do the same thing with this 16 thing, just so we can have some easy time dealing with. I'm just gonna do local chunk size equal to vector3.new. well, I'm gonna give it 16 by 16 by 16. Cool. Now we can just, here in the position, we can just do times chunk size, and it's done. Well, now I can just do 1 and I can run. And yeah, we have 2 chunks. Cool. Let's try some more. 4 chunks. Okay. Well, cool. We have now 4 chunks. Cool. What we got, well, we can actually calculate. Let's just get a calculator actually, without using the command line. So yeah, 16 times 16 times 16 times 4, because we have 4 chunks. So this is the actual number that we just generated by our code. Yep, this little functions. So yeah, now I'm actually gonna end this episode right here. We probably doesn't actually cover anything from math.noise, but we're just making a foundation, or making a real problem that we're gonna use on this freaking cool function. I hope you like this video. Doing my best to teach you what I have in my mind, probably. And sorry if I have any wrongs in the grammar or whatever, because I'm Arabic, by the way. If you don't know that, I'm Moroccan, so I'm sorry for that. And thank you for watching. So if you have any suggestions, by the way, make sure to comment it down and like the video if you liked the video, and dislike it if you disliked the video. So, and make sure to subscribe if you aren't, so you can stay tuned and just get the new cool creations of Roblox and tutorials. So I hope I actually shared with you, or just teach you some information. And well, yeah, thank you for watching. See you there. See you next time.